So our instructions say solve the following system using elimination. Classify the system as being consistent or inconsistent, and the equations as being dependent or independent. Now, when we look at using elimination in your notebook on page 71, I think, it says use one equation to eliminate the same variable from the other two equations. Solve the resulting system of two equations. Then substitute the values back into one of the original equations to find the third variable. So what I like to do is I'm going to number my equations. So this is going to be equation 1, equation 2, and equation 3. And the whole point is to get one variable to drop out. Okay, so what I'm going to do is I'm going to choose equation 2 and 3 first. Okay, so the reason I'm choosing equation 2 and 3 is because in equation 2 I have a positive z, and in equation 3 I have a negative z. So I'm going to take equation 2 and equation 3, and I'm just going to add them together. So adding these together, I get 7x plus x is going to give me 8x, and 3y plus y is going to give me 4y. And the z, positive z and negative z, will cancel out. And so 4 plus 0 gives me 4. So now I have a new equation here. Now, in order to continue on, I have to choose another pair of equations from the first set and eliminate that same variable again. So what I'm going to do is I'm going to choose equation 1 and 3 because, again, I've got a positive and negative z situation. However, equation 1 has 6z and equation 3 has just negative z. So I'm first going to multiply equation 3 by 6. I don't know why I wrote 3 up there. Sorry. Let's make that a 6. Okay, so multiplying by 6, I'm going to get 6x plus 6y minus 6z equals 0. Okay, so now I'm going to add to it equation 1. Okay, and adding these two together, 6x plus 3x is going to give me 9x. 6y and negative 2y is going to give me 4y. And the z's cancel out again, and it equals 1. So now I've created two equations that are down to two variables. Okay, so now I'm going to try to eliminate the same variable from each one. So now I'm going to call this equation 4 and this equation 5. Okay, so I'm going to take equation 4 and multiply it by negative 1 and add it to equation 5. Okay, so if I take equation 4 and multiply it by negative 1, I get negative 8x minus 4y equals negative 4. Now, if I add that to equation 5, so just writing equation 5 on top, positive 9x plus negative 8x is just going to give me x. 4y and negative 4y cancel. And 1 and negative 4 make negative 3. So now I have officially solved for one of my variables. Okay, so from this point, we're going back and substituting into each of the equations. So I can choose either equation 4 or 5 to plug this x equals negative 3 in. I'm just going to choose equation 4 because it's easier, it's fewer numbers. So I'm going to do 8 times negative 3 plus 4y equals 4. Okay, 8 times negative 3 is going to be negative 24. I add negative 24 to both sides, and I get 4y equals 28. And solving, I get y equals 7. So now I'm down to two variables that I know. So I only have a remaining single variable. So if we scroll back up to our beginning equations and we look at them, which equation is easiest to use to solve for z? Well, to me, it looks like equation 3 because it's just x plus y minus z equals 0. So I'm going to do, remember, it's x plus y minus z equals 0. So plugging in what we have already, I've got a negative 3 for x, a 7 for y, and a negative z equals 0. Negative 3 and positive 7 are going to make 4. 4 minus z equals 0. We're going to subtract 4 from both sides and divide by negative 1. And I get z equals 4. Now, because we have 3 variables, we would write our solution as an ordered triple. Okay, so then the actual solution, and this is a single, excuse me, this is a single solution. So because it's a single solution, we would consider this system to be consistent and the equations independent.